Exponential growth and decay. This concept applies on exponential equations or type of exponential equations. Generally speaking, in our syllabus, we have this formula based on compound interest. If you have done compound interest, so compound interest formula for compound interest is amount is equal to principal into 1 plus r upon 100 whole power t. And in this formula for compound interest, A represents the amount, the total amount. When I say total amount means the amount which has been increased after the interest being added. R represents the rate, the interest rate, and T represents the time. So this compound interest formula is also the case of exponential equations. And in particular, compound interest formula is the case of exponential growth only. This was the case of only the exponential increase or exponential growth. Why exponential increase or exponential growth? Because if you have borrowed the money from the bank and after a certain period of time, if you have to return the money, so that return money has to be an increased value. By increased value, it has to be the sum of the interest charged plus the amount borrowed. So compound interest is the example or the case of exponential growth only. Exponential growth, or I say exponential increase. But here in this lecture, we'll be talking about other scenarios also where we can apply the concept or equation of compound interest. And what happens is, other than financial terms, other than money involved, we have the exponential concepts applied on different scenarios also. And then we can also expect the cases of exponential decay. In simple words, I can give you the example of the COVID-19. COVID-19, the time of coronavirus, we saw that initially when this virus came into play, the people were getting infected at a very higher rate. If one of the member in the family gets infected, so that virus would eventually transfer to the other members of the family also. So that is the reason why the virus was increasing exponentially. So the initial period of virus, it was the example of exponential growth. Why exponential growth? Something it was increasing at a very high rate. And when I say exponential growth means something which rises at a very high pace, at a very high rate. So that was the initial phase of COVID-19 or the phase when the virus started to spread. So something was increasing at a very high rate. And then, let me write this. This was a case of exponential growth. Something increasing at a very high rate. And then after a certain time, the scientists work on the vaccination. And when vaccination was introduced in the market, after the people being vaccinated, the infection started falling. And at the very high pace, the infected person started falling after the vaccine was introduced in the market. So something start falling at a very high rate. And this phase occurred after the introduction of vaccine in the market. So that you can consider as a case of exponential decay. So this is one example from the real world scenario where you can see the case of exponential equations involved. So other than compound interest, other than the financials, other than the money borrowed and money invested, we can see the compounding concept or the exponential growth and decay concept applied. And the changes in the formula now is this A, instead of A, we have A is equals to P 1 plus R upon 100 whole power T. The formula is still the same, but now the variables would be having different meanings. A, this would now mean the increased or the decreased value. If it's the case of growth, so it would be an increased value. If the case of decay, then it would be the decreased value. P, it will not be the amount invested or amount borrowed. Now P would be the initial value. Initial value means from where we started. R, it would now be the growth rate or the decay rate. The percentage, the rate at which something is increasing or something is falling. So it's the increase or the decrease rate. And T here, it represents time. Now don't mix up time with years only. For financial terms, it was mostly in years. Like when we say compounded annually or interest is applied or interest is charged per annum. So there it was all about years. But in case of compounding applied for growth and decay, the time can be either in terms of years, it can be in terms of months, it can be in terms of days, it can even be in terms of minutes. So whatever, and yes, seconds also, although we haven't seen any past paper question based on seconds, but yes, second is a unit of time, so you can expect seconds also. So T here means time representing years, months, days, and minutes. Now let's move on. So overall, I have divided this topic into three main type of questions. The first type of question, the first category of question is about finding A, which is the increased value. Second set of questions would be about finding R, the rate at which something is increasing or decreasing. And the third type of questions would be about finding the time. Always remember, one single formula, it's not necessary that it would be used to find only one single thing. No. One single formula can be used to find all the variables attached to that formula. For example, if you have area formula for a rectangle, although the formula is length times breadth, but area formula can also be used to find length when area and breadth is given. And so do it can be used to find breadth also when area and length are given. So this is how we'll go on. First, we'll solve questions based on finding the increased or the decreased value. That is A in the formula. So this would be one single formula what we would be using throughout. All right, finding the A of the formula, the increased or the decreased value. The first example, the red squirrels are entering the UK at a rate. Entering means this would eventually be the case of increment. At a rate of 5.2% per a year, currently there are 590. So currently means they are talking about present. And when we say present, present means the initial value. There are 590 red squirrels in the UK. What is the expected red squirrels after 6 years? After 6 years, that means we are interested in finding an increased value. So we have to find here A, which is the increased value. Rate, that is given as 5.2%. Currently, there are 590. So that means this is the initial value. Initial value. And we represent initial value by P of the formula. That is 590. And we have to find the expected red squirrels after 6 years. After 6 years means the time is 6 years. So making the use of the formula, this is A, which is equal to P into 1 plus R upon 100 whole power T. So A, the increased square is to be found. P, it's 590 into 1 plus the rate, that is 5.2 upon 100 whole power 6. So using the calculator, we will have this as 5.2 divided by 100 plus 1 raised to the power 6 multiplied by 590. We're getting this as 799.7. When rounded to three significant figures, it would be 800 squirrels. Any questions up till here? Anything which is not clear? Okay, I don't see any questions. Let's move on. In this example, it says on Tuesday, 30,000 people tested positive for COVID-19. The health secretary estimates the case increases 4.7% a day. So we have the initial value, which is the 30,000 people. They are increasing by the rate of 4.7% a day. We have the rate as 4.7% a day. How many more people have test positive on Sunday than on Tuesday? On Sunday than on Tuesday, more people, more people. That means we have to find the difference. And to find the difference, we first need to find the people, the total people who are infected by Sunday. So by Sunday, Sunday means we started from Tuesday, and Sunday, that means the time taken would be Wednesday, Thursday, Friday, Saturday, Sunday, 5 days. The time, that is 5 here. Okay, using the formula, A is equal to P into 1 plus R upon 100 whole power T. A, that is to be found the increased value because patients are increasing. Initially, it was 30,000. 1 plus rate, that is 4.7 upon 100. Time, that is 5 days. So after 5 days, the total infected people, I'm using the word total. So total infected people, that is 4.7 divided by 100, 1. You are getting this as 37,744. 37,745. We have rounded off. So these are the total infected people. These are total infected people on Sunday. And the question says how many more? How many more means this is the case of subtraction. We have to find the difference of the people who were infected on Tuesday and the people who are infected on Sunday. So the difference here is that would be equals to 37,745 minus 30,000, which is 7,745. So both these examples were the cases of exponential growth or exponential increase. Now let's have a scenario of exponential decrement. Carlos buys a motor scooter for 1200. Each year, the value of the scooter decreases by 10%. Decreases by 10%. So decreases by 10% means the R it is, since it's a case of decrement, so you can also write this as a minus 10. So 10%. It's a case of decrement. It was bought for $1,200. That means $1,200 was the initial price. Find the value of the scooter after 3 years. After 3 years, that means the time is 3 years. Okay, now there would be a slight change in the formula for the increment. For the increment, something is being increased, so we are using a plus sign. We are using a plus sign here. But for the decrement, for the decay, for the decreased value, there would now be a minus sign in between. So for decrement, for decay, for decrease, you use a minus sign now. 1 minus R upon 100 whole power t. So A, that is to be found the decreased value, the depreciated value. Initial value, it was 1200. 1 minus the rate is 10 upon 100 whole power 3. So we get the depreciated value as 0.9 raised to the power 3 multiplied by 1200. We are getting this as 874.8. So $874.8. So this was the example for exponential decay. Let's do another example based on exponential decay. The population of Orton is decreasing at a rate of 3% per year. Now we have the unit as per year, 3% per year. So we have the rate given as 3% per year, and it's the case of decrement. In 2013, the population was 50,000. Calculate the population after 4 years. After 4 years means this 50,000 would become the initial value for us, which is P. So P, it is 50,000, the initial value. Time, that's 4 years. After 4 years. And we have to give the answer correct to the nearest 100. So we'll use the decay formula only. A is equal to P into 1 minus this time R upon 100 whole power T. So A is equal to P, the principal, that is 50,000. 1 minus the rate, it's 3%, whole power 4. So we'll get the answer as we're getting the answer as 44,264.64. Since the question says nearest 100, we have to round it off to the nearest 100. So that would give us the value as A is equals to 44300. That is correct to nearest 100. So these were all the examples about exponential growth and decay both. And these are all about finding the increased or the decreased value. Any questions up till here? Because now we are moving on to the second type of question where we have to find R of the formula, the rate. Do we have any questions until here?
No, sir.
Okay. Now, the second type of question. Now, we have to find the increase or the decrease rate this time, not the increase or decrease value. Rate means now we have to find R of the formula. Okay. Over a period of 3 years, the company's sales of biscuit increased from 15.6 to 20.8. So from 15.6, that means 15.6 was the initial value for us. That is P for us, 15.6. You don't need to write the zeros of million. We keep the answer with the unit millions only. So you don't need to write the 6 zeros representing the million. So P, the initial value is 15.6, 20.8, that is the increased value given to us, which is A, 20.8. The sales increased exponentially. They are using the word increased. Increase means R will go with a positive sign. By the same percentage each year, calculate the percentage increase each year. We have to find the rate here, R. Time is given that it happened over a period of 3 years. So time is 3. So we start with the same formula because it says exponentially. So exponentially means we will start with the same formula, and that is A is equals to P into 1 plus R upon 100 whole power T. So we have the A given to us, which is 20.8. We have the P given to us, that is 15.6. 1 plus R is something what we need to find, whole power 3. So we are interested in finding this variable, which is locked inside the cube. And to get this variable outside the cube, you have to cube root. That's one simple rule. So before taking cube root, you have to first separate the things. We'll do some simplification there. So we can write this as 20.8 upon 15.6 is equals to 1 plus R upon 100 whole power 3. And to finish this power 3, we have to cube root both sides. Cube root both sides. So what happens is this cube root would cancel the cube. And on the left side, you have to apply the cube root of 20.8 and 15.6. Let me find the value.
4 upon 3.
4 upon what? Hello. What was the answer? 20.8 divided by 15.6 whole
4
cube
by
root
3.
4 by 3 is equals to 1 plus r upon 100. Try to maintain the fraction to have the better accuracy of the answer. It would now be 4 upon 3 minus 1 is equal to r upon 100, and then 100 into 4 upon 3 minus 1 is equal to r. What is the final answer?
Cube root of 20.8 upon 15.6 is 1.10.
Can anyone else
My answer is
please?
also 1.10.
Yes,
Okay.
I'm also getting 1.10.
So I think that was 1.106, or is it
1.1006.
okay? So now that's 1.1006 minus 1, and that would be 100 into 0.1006. We are getting the rate as 10.06,
Yes.
and for three significant figures, it would become 10.1%. Is this clear to all?
Yes, sir. Yes.
Okay. So that was the case of finding R with the exponential increment. Now in this example, it's again R to be found, but this time this is a case of exponential decrement. Example. Now here the question says the number of newspapers sold decreases exponentially. They have used the word exponentially and it decreases. Decreases means something is falling. By X% each year. X% each year means the rate. This is X% each year. Over a period of 21 years, time is given. 21 years. The number of newspapers sold decreases from 17 lakh 63,000 to 58,000. So please be clear about the initial and the final value. It started from 17 lakh. So P for us, it would be this 17 lakh 63,000. And A, the decreased value or the depreciated value, that is 58,000. Time is 21 years and we have to find X, the rate. So we start the same formula, and that is A is equal to P. And this time it's a case of decrement. So make sure you're writing a negative sign here. R upon 100 whole power T. So A, the decreased value, this is 58,000. Initial value, that was 1763000. 1 minus rate is something what we need to find, that is X upon 100 whole power 21. So it would now be 58,000 upon 1763000 is equal to 1 minus x upon 100 whole power 21. Now here at this stage, students get confused at how to get rid of this power 21. And the simple rule is, look, previously it was a power 3 to be finished, power 3. So we took a cube rule. So we were supposed to finish a power 3. And to finish the power 3, what we did? We took a cube root. Cube root, we know that that's power 1 upon 3. So in simple words, and consider the case of square and square root. For square to be finished, power 2. For square to be finished, you take square root. That is power 1 upon 2. So the bottom line is, whatever power is to be finished, you always take a reciprocal of that power. The same would be the case here. You have to get rid of this power 21. So you simply take the reciprocal of this power, both sides. I'm using the word both sides because in equations in maths, the same operation has to be applied on both sides of the equation. So what you do is you take 58,000 upon 1763000 whole power 1 upon 21 both sides. 1 minus x upon 100 power 21 whole power 1 upon 21. So eventually this 21 cancels 21. And for the left side, you have to use the calculator to find the value. Can anyone help me in finding the value?
Zero point 150. 0.849.
Sir, the answer is 0.8499.
Yes, 0.8499. Okay, so now we'll do some algebra here. So it would now be x upon 100, move this side, is equal to 1 minus 0.8499.
0.15.
And finally, this would be x is equal to 100 into this 1 minus 0.8499. What is the final answer?
15.
3 significant figure.
15.005.
So that would become a 15 only.
Yes.
Okay, so both these examples were the case 2. Case 2 means finding the rate of exponential growth or decay. Any questions up till here?
No, sir.
Now the last case, the last type of question, and that is finding the power this time. Finding the power means looking at the formula again. Now we would be dealing with finding this. We have dealt with finding A, we have dealt with finding R, now finding T. Okay, now in this example, here it says it is estimated that the world's population is growing at a rate of 1.14% per year. Find the expected population on January 1st, 2020. Expected population is it's a simple scenario, the case 1, where you have to find the increased value. I'm directly using the formula here. The increased value to be found, initial population that was 7.23, 1 plus rate that is 1.14 upon 100, and we have to find in 20. It started from 2014 and we have to find that of 2020. So that would be a period of 6 years, the power 6. Can anyone tell me the answer here?
7.738.
7.738. Can anyone else please confirm? Three significant figure, it would become
Yes.
7.74. Okay, so that was part A of the question, which was simply about finding the increased value. Part B is something what I'm interested more. Uh, find the year. Find the year. Year means we have to find the power, the n, the t of the question. When the population is expected to reach 10 billion, 10 billion, then that means we are now given with the increased value here. So A, this is 10 now. P, that was 7.23. Now time is unknown this time. Rate is given, which is 1.14. So we'll use the formula here. P is equals to uh, A is equals to P into 1 plus R upon 100 whole power T. A, that is 10, is equals to P, that is 7.23, 1 plus rate, that is 1.14 upon 100 whole power T. Simplifying it further, that would be 10 upon 7.23 is equal to, solve the bracket also. So 1 plus 1.14, that would be what? 1.0114 whole power T. And what is the value of 10 upon 7.23? 10 upon 7.
1.383.
That is
1.33.
Okay, so 1.383 is equal to 1.0114 whole power T. Now this is a very special type of equation in our syllabus. This type of equation is called as exponential equation. In maths, we have two methods to solve exponential equations. One method is trial and error, which can take some time. And the other method in our syllabus is logarithms. Not our syllabus, but in maths. Logarithm. Now, logarithms or logs, this is not part of O levels or IGCSE syllabus. This is a part of O levels or IGCSE add math syllabus. So those students who have add maths with them, they can apply logarithms. There is no restriction of method to be used in maths. You can apply all the methods and all the formulas in maths. So those who know logarithm, they can apply logs there to solve this equation. But those who don't know logarithm, they don't have add maths, so they have to go for trial and error only. So since this is maths based class right now, so I am teaching the trial and error thing, not the logarithm thing. But I know I have a few students in this class who have logarithms. So yes, you can apply the logs there to solve this equation. So I'm using trial and error. Now, trial and error means you keep on trying until you reach your required value. So you keep on trying. You keep on trying means you keep on raising this t until you cross this 1.383. So you keep on trying. So keep on trying, applying random values of t so that you may cross 1.38. I'm using the word cross. That means you have to exceed this. So start trying it. 1.0114 raised to the power, if I'm raising it to the power 5, I'm getting this as 1.05, which is far away from 1.383. So I'll give a jump to it. For 5, I'm now taking it as 15. Taking 15, I'm getting this as 1.18, which is still far away from 1.383. So instead of power 15, I'm taking this to power 25. You can take these jumps. Now, taking 25 as the power, I'm getting the answer as 1.32. I'm getting closer now. 1.32 is closer to 1.38. So I have to, I think, go 2 or more values ahead. So in place of 25, now I'm using 27. 27 is giving us 1.35. So we are just one decimal away. If I take this as 28, no, 28 is giving me 1.37.
29.
But if I do 29, yes, 29 makes me cross it. So 1.0114 when raised to the power 29 gives me 1.389, which is greater than the value 1.383. So that means the time it took is 29. The unit of the time here is years, 29 years to surpass this value. And the question was asking for the year. Find the year. That means the year, it has to be, it started from the year 2014. So 2014, it started in, it took 29 years. So 2014 plus 29 would take us to what? 24.3. Please confirm if I'm right.
Yes.
Okay, so this is how you handle the unknown powers to be found. This is how you solve the exponential equations in case of exponential growth and decay questions. Any questions there?
No, sir.
So this was the case of exponential growth to find the unknown power. Now exponential decay to find the unknown power. Now this again, it's a slight different question. Here the question says, Gwen bought a new car. Each year, the value car of a car depreciates. Depreciates, that means it's the case of decay. Calculate the number of years after which the value of a car was 47% of its value when new. Of its value when new. We don't know what was the value at new. Don't know it. That means here neither we know the initial value nor we know the change value. I'm using the word change value. Change value means change can be either the increased value or the decreased value. So here neither we know A of the question nor we know P of the question, the initial value and the decreased value. So when you in such scenario, when you don't know the initial value, you always suppose a variable for it. So let the initial value be which is P for us. Let this be X. And the decreased value, the depreciated value, which for us is A, and that is 47% of the price at new. So it would simply be 47%, 47% of the initial value, which was X. So we can write this as 47 upon 100 into X, which would eventually be 0.47X. Because 47% means 47 upon 100 times x. So 47 upon 100 times x, that would simply be 0.47x. So this is A for us. So we've got P and A in terms of x. Now we'll make the use of the formula. A is equals to P into 1 plus R upon 100 whole power T.
1 minus R होगा.
Oh yes, it's a case of decrement, so it has to be 1 minus R. A, the decreased value, that's 0.47x. P, the initial value, that's x. 1 minus the rate, that is 9 upon 100 whole power T. T is something what we need to find. Simple algebra, this x, when goes on the other side, would eventually get cancelled. How? It would now be 0.47x upon x is equals to 1 minus 9 upon 100 whole power t. So you see x and x get cancelled. So this is how you simply handle such situation when you don't have the initial and the increased or decreased value given. 0.47, 1 minus 9 upon 100, you have to simplify this as well. So 1 minus 0.09, that would be what? 0.91 whole power t. And now here again, you have to go for trial and error. It's an exponential. Those who know logarithm, they can apply logs. Those who don't know logarithms, they have to go for trial and error. To keep on raising the power of 0.91 and tell me once it gets below 0.47. I'm using the word below. The previous question was about growth. So we kept on increasing the value until we surpass the value on the left. Here, it's a case of decrement. So we keep on raising the power until we get below 0.47. So 0.91 power, if I take 5, so 5 is taking me to 0.62. If I make it 9, 9 is making me 0.42. I have to check for 8 also. 8 is making me 0.4702. Eight is giving 0.4702. 9 is giving 0.427. So I have to go for power 9. 0.4279. So T has to be 9 years. Is this clear, guys?
Yes.
Okay. If this is all clear, then I want you people to try solving these two questions. These two questions, this question number 1 and this question number 2. You have 5 minutes of time. Not question 3 because we don't have enough time. So this question 1 and 2. Okay, so these are the correct answers. This one is for question number 1 and this one is for question number 2. Hope you've got the correct answer. And then there was this one more question. You can try this as well. So this is it. This was all about exponential growth and decay. Thanks for watching.